Greetings, my name is Professor Duke Orata. We are continuing with our lectures, and today we want to look at the pressure at the throat, because at the throat, this particular duct, when you have flow, at the throat, that's where the mass flow rate per unit area is maximum, and so we can compute the pressure at that particular point by taking the derivative of the expression we derived in the last lecture, where remember the mass flow per unit area we had said was 2n, 1 minus n, into P1 by V1, into P2, P1, n plus 1 over n, minus P2, P1, 2 over n. All this quantity under the square root. We have derived the past lectures. Please, I encourage you to go through our other lectures. Well, don't be surprised as the way I'm dressed. I was working on my engine. There was a lot of oil on my plugs, and so I was checking my oil rings if they're intact, and of course the valve seals. So if you look at our discussions on internal combustion engine, this is where we have talked about the practicalities of converting your theory into practice, and I encourage you to look at that particular lecture. It's important that you are able to practice what you know also in theory. And so we are saying mass flow per unit area. We got this particular expression. And remember that that n was the isentropic index of expansion in our polytropic equation, which we had derived earlier. So let's just rearrange this particular expression. We have said that to find the value of pressure at the throat, where the mass flow per unit area is maximum, we can get that pressure by taking the derivative of this expression and getting the P2. So let's just simplify it by removing our square root. So if we remove our square root, of course, that will be squared. So that should be 2n into 1 minus n, P1 over V1 into P2, P1, n plus 1 over n minus P2 over P1, 2 over n, 2 over n. And so our life is becoming a lot easier. So we can remove the V1 from that particular expression to make our life easy. So we can take it to this particular side. So we have our V1 as being equal to 2n into 1 minus n, P1, P2, P1, n plus 1 over n minus P2 over P1, 2 over n. And you need to be very careful when you're dealing with these types of quantities. Now, we can simplify by realizing that this is P raised to power 1. And if we take it into this particular bracket, if we take it down here, then what we'll have, remember, if we use the identity, if we have x to the n, that is 1 over x to the minus n. That would be 1, the x minus n. And so we can apply that here so that we integrate that into that bracket there. So we have m over a2 into v1 a2 squared, v1 is equals to 2n to 1 minus n. And remember this particular bracket here, P2 over P1 for this ratio of pressures is each is P2 raised to power n plus 1 over n over P1 raised to power n plus 1 over n. So we can bring in the P1 there by having that as P2 n plus 1 over n over P1 n plus 1 over n times P to the minus 1. And the same applies to this second term here. Again, that one will be P2, 2 over n, over P1, 2 over n times P1 to the minus 1. So we have just used that particular identity, applied it to P, 1, value for P1. And what did we say? Let's simplify this expression. So if we simplify, we have m over A2 squared V1 as being equal to 2n1 minus n into P2 n plus 1 over n over. Now, we use the identity. We have the two exponents, P1 n plus 1 over n times P minus 1. We add the exponents. So just remember that you don't take for granted. You have m to the n times m to the x. That will be m to the n plus x. So we will use that here. Remember that was P1. Sorry for that. That was P1, which we got it from there. So we can use that law of exponents. And so we have, this particular one will be P1 n plus 1 over n minus 1. And the other one will be minus, we have minus sign there, we have forgotten to write it, minus P2, 2 over n over P2, 2 over n minus 1. So let's label these things. Let's call this 1, expression 1, expression 2, expression 3, expression 4, and expression 5. Now, we can move on. We said that this is not P2, this is P1. P1. So we have seen that that is P2, that's P1. So if we simplify that, that will be n to n plus 1 minus n. So that will be 1 over n. So we have m over A2 into V1 squared is equals to 2n over 1 minus n into P2 n plus 1 over n plus 1 over n over, if you open up this, so we will have P1 n plus 1 minus n, so that will be 1 over n minus P2 2 over n over P1 2 over n minus 1. So let's just make sure we've gotten everything right. So we have for our Pn plus 1, so that is Pn plus 1 minus 1, which is what we have here now. And so if you open up that quantity there, then you're going to have as n, as the LCM, of course, will be n plus 1 minus n, and that will be 1 over n. Now, we want to take the derivative of this quantity here. We want to take the derivative of this quantity here with respect to P2 and equate to 0. So we want to take your P2 and equate to 0. And so what we have, of course, this side will be 0 because there is no P2. So what do we have? So we have 0 is equals to 2n into 1 minus n, and we take the derivative of these quantities d of dp2 into p2 n plus 1 over n into p into 1 over n minus p2 2 over n to p1. This is p1, p1 2 over n minus 1. So I want to take the derivative here. And you notice that this is not just a simple derivative. We are dealing with a quotient there. So we'll use the quotient rule from differential calculus. So we'll use the quotient rule from the differential calculus. And let's just remind ourselves of what the quotient rule is. Let's remind ourselves of what the quotient rule is. We have used the product rule repeatedly. Let us use the quotient rule. So we are using the quotient rule. And the quotient rule is very simple. du over v will simply be v du minus u dv over v squared. So what do? We can treat that as, that can be our u. We can consider the numerator here as u, and that as v. And consider our u, that as u, and that as v. So we apply the quotient rule. So if we apply the quotient rule, so on applying the quotient rule, we will have 0 is equals to 2n over 1 minus n. So now that is v, that is into p1, 1 over n, p1, 1 over n, that's v, then d of p2, n plus 1 over n, dp2. dp2, that is our v du, and then minus u dv, which will now be p2 u dv p2 n plus 1 over n p2 dv d of p1 1 over n dp2. That is the first expression here for this particular quantity there. Let's call that A. Let's call it A. So that is application of the quotient rule to A. Then we have minus. We're applying to the second term. Let's call that B. Applying the quotient rule to B, we now have minus V. V is P1 2 over n minus 1 V du, which is d of P2 2 over n dP2 minus u dv, that is P2 2 over n d of P1 2 over n minus 1 d, that is u dv, v du. Now u dv, u is that is dp2. But remember, we have forgotten something. We have not put the v squared, so we need to have our v squared here. Let's not forget that. We have our v squared there for a. What is our v squared? V squared is P1 1 over n squared. And in this particular case, it is P1 2 over n minus 1 squared. Now, remember, we have taken the quotient, we applied the quotient rule to term 1, term A, and term B. And that is term A, and that is term B. So let us move on. There are simplifications. Move on with our simplification. And so what are we saying? We are saying that 0. Now, if you look at this particular quantity, that is P1 raised to power 1 over n, P1 raised to power n over n squared, so we can divide that with that. We are left with P1. So we'll have 2n over 1 minus n into dP2 n plus 1 over n over dP2 minus we have that quantity, that is minus P2 n plus 1 over n We don't need this term. Why don't we need that particular term? Notice we have dp1, so that term is 0. We don't have p2 there, so that term is 0. So our life is easy. So let's forget that. So this is simply over p1, 1 over n. I repeat, this derivative is 0 because there's no p2 here. So when you take the derivative here is with respect to p2, there's no p2, so that term is 0. And so even in this particular case, this particular term will be 0. Just make sure we have taken the derivative of p1 with respect to p2, and that term will be 0. And of course, this p1, 1 over n, will divide this one, so we are left with p1, 1 over n raised to power 1. And so we have in this particular case, in the other simplification now, we have again this p1 raised to power 2 over n minus 1 will divide by that, so we'll be left with dp2, 2 over n, dp2 over p1, 2 over n minus 1. This is the term we have. So we now use the simple expression, taking derivatives. The derivative of x to the n is simply n x to the n minus 1. So we'll take the derivative there. So we have 0 is equals to 2n over 1 minus n. And of course, that will be n plus 1. Therefore, that will be n plus 1 over n plus 1 over n, and when you take the derivative of that, will be into p2, n plus 1 over n minus 1. Just use that identity for differential calculus, and over, this is over p1, 1 over n, minus, this now will be 2 over n, p2, 2 over n minus 1, divided by p1, 2 over n minus 1. So the things we are improving, we are getting there. So we have these particular terms. And of course, if we take this, we can take this quantity, this side, so that the negative becomes positive. Of course, 2n over 1 minus n will be multiplied by this quantity here. 2n over 1 minus n multiplied by that quantity there. When we take it to that side, we can cancel both. We will cancel both 2n over 1 minus n. So we'll be left with 2 over n p2, 2 over n minus 1 over p1, 2 over n minus 1 is equal to n plus 1 over n p2, n plus 1 minus 1 over n over p1, 1 over n. So I repeat, we will have multiplied both sides by 2n over 1 minus n, 2n over 1 minus n, so we can cancel both of them. So we are left with those particular quantities there. Let's see if we can simplify it further. So what do we have? So what do we have here? We can choose to take the n plus 1 this side, just cross multiply by n over n plus 1. So we can, on further simplification, and simplify it further, and multiply 2 over n times n over n plus 1 p2, 2 over n minus 1 over p1, 2 over n minus 1 as being equal to p2, n plus 1 minus 1 over n over P1, 1 over n. So remember, we have just cross multiplied n over n plus 1. Move that, will be 1, because we get the quantity which you get there. That will be 2 over n plus 1. And that, we can collect the like terms. We can collect the like terms, the P2s and the P1s together. So we have P2 n plus 1 over n minus 1 divided by P2, 2 over n minus 1, and we have P1, 2 over n minus 1 over P1, 1 over n. So we just collected the two terms. We have just collected the two terms. Let's try to simplify it. 2 over n plus 1. That, of course, this is 1 over n. That will be n plus 1 minus n. That is n plus 1 minus n, so it will be 1 over n. That will be P2, 1 over n over P2, 2 over n minus 1 times P1, 2 over n minus 1 over P1, 1 over n. So simplifying these expressions further, let's see how we can simplify them further. If we take this up, remember, the sign changes. So we will have P2, 1 over n times P2, 1 minus 2 over n. We have changed the sign. We had indicated that x over n, x raised to power n is 1, x to minus n. So that sign will change to be 1 minus that, because you're multiplying the negative of that quantity, divided by P1, 1 over n times P1, 1 minus 2 over n. So let us simplify these expressions using the law of exponents. Simplify them further. Simplify the exponents. So we have 2 over n plus 1. That will be P2. Now, we are adding the exponents. 1 over n plus 1 minus 2 over n. That will be 1 to 1 minus 1 over n plus 1 minus 2 over n. And this will be P1, 1 over n minus 1 minus 2 over n. And so what do we get here? When you simplify these quantities, that would be 1 plus 1 minus 2. That is 1 minus 1 minus 2. What do we have here? 1 plus 1 minus 2. So we will have P2, n. That will be 1 plus n minus 2. This particular case. This other one will be P1, n, 1 plus 1 plus n minus 2. And so that will be 2 over n plus 1. One has to be careful with these exponents, especially when we're dealing with so many of these quantities. One has the bookkeeping is critical, because you miss out on a sign, you lose your way. So you have to do it systematically and very, very clearly. You must have a proper direction on how you are going to do the thing. So what do we have here? So that would give us, so what do we have here? That is n minus 2. So that would be 1 P2 into n minus 1 over n P1 into n minus 1 over n. And so we see that the exponents are common, so we can pull it out of the bracket so that we have P2, P1 into n minus 1 over n. And of course, we can use the identity which we know. If we have x to the n over m is equals to y, this can be written as x is equals to y m over n. We can take that exponent to y by simply dividing this with that, both sides. And so we can do the same here. So we will have 2 over n plus 1, 2 over n plus 1, the n over n minus 1 is equals to P2 over P1. And therefore, the expression for pressure at the throat, where the mass flow per unit area is maximum, is given by P1 into 2 n plus 1 into n over n minus 1. That's our expression of pressure for pressure. That's the expression for pressure at the throat, where mass flow is maximum. Maximum. That's the expression for pressure. P2 is this. P2 is the